Hello everyone, my name is Ogenete Mary Mamogo and you are welcome to Oak Scheme Academy. Now if you are new to my channel, kindly hit the subscription button below, also like, share and of course avail yourself to the lessons so as not to be left behind. Welcome back. So in today's lesson, we're going to be learning how to calculate or solve problems under Gay-Lussac law, which is under the broader topic of gas laws. So we have learned how to calculate for Boyle's law, Charles' law, and also general gas law. So we're going to be moving on to what Gay-Lussac's law. If you are yet to watch those lessons under these topics I just mentioned, kindly check them out on my channel titled Calculations under Boyle's law, Calculations under Charles' law, and Calculations under general gas law. So we're going to be moving on to Gay-Lussac's law of combining volume. But first things first, what does this law state? Gay-Lussac's law of combining volume states that when gases react, they do so in volumes which bear a simple ratio to one another and to the volume of their products if gaseous, provided that temperature and pressure remains constant. So that is what Gay-Lussac's law of combining volume states. So Gay-Lussac's law has to do with volumes. You really have no business with temperature, pressure, just volume. So it is called Gay-Lussac's law of combining volume. So we have 3 questions on the board that we're going to be solving to better understand how to solve for Gay-Lussac's law problems. So the first question on the board, calculate the volume of oxygen required for the complete combustion of 0.25 dmq of methane at STP. So that is the first question. Now this, you can see that this is very different from Boyle's law, Charles' law, or general gas law. So there's no mention of temperature, there's no mention of pressure, it's just volumes. Now, when you are solving for Gay-Lussac's law of combining volumes, one of the things you have to learn or be required to know is how to derive products from reactants. That's how to write an equation, a chemical equation. And another thing is how to balance a chemical equation. So I'm going to be dropping a video or a lesson on how to balance chemical equations soon. So stay tuned for that. And also how to derive products from reactants. But for the sake of this video, I'm going to be doing it on our behalf. Hopefully you can follow along. So like I said, the first thing when solving the Gay-Lussac's law question is they're going to be required to write out an equation. So we're given a question. The question says, calculate the volume of oxygen required for the complete combustion of 0.25 dmq of methane at STP. So the first step is to write your equation. Without an equation, you cannot solve a problem under Gay-Lussac's law. So how do we write the equation? So we look at our compound or element given. So we're given oxygen and we're given methane. So methane's formula is CH4. So please take note of that. The formula for methane is CH4. Now sometimes some questions can give you the formula in a bracket, but not all questions, as you can see with this. So always learn your compounds, learn your chemical compounds. So methane is CH4, and they told us that methane reacted with what? Oxygen. So plus what? O2. So please remember that oxygen is a molecule, or rather oxygen gas is a molecule. So don't just write O2. So that's how we know that this is a gas. Okay? So once you have done that, whenever methane, or rather whenever you see carbon and oxygen in an equation, so I'm trying to explain how compounds are formed, although I will be doing a more elaborate video later on. So whenever you see carbon and oxygen together, just know that CO2 must be formed. And then whenever you see hydrogen and oxygen present in a reactant, just know that water must be formed, which is H2O. Once you have written your two products, you can now balance. So you don't balance until you have written your products. Once you have written your products, you can now balance the equation to ensure that each element are of equal number on both sides. So to balance this equation so that we do not waste time, we're going to place 2 here and we're going to place 2 here. So when you place 2 and 2 here, you score that this equation is balanced. So check that out and let me know whether you're able to do that on your own. So but when you look at this equation, it's balanced. The number of carbon on each side is balanced. The number of hydrogen on each side is balanced, and also the number of oxygen on each side is equally balanced. So now that we have written our equation, the next thing you want to do is you can now begin solving. So we're going to be writing, remember it is Gay-Lussac's law of combining volumes, so we are adding volumes. So this is what we're looking at. This is what we're looking at. What is in front of your compounds is what we are looking at. So we're going to be writing 1 CN cube Remember, in chemistry we do not write 1, but we know that there is a 1 here. It's an invisible 1. So 1 cm cube, 2 cm cube, 1 cm cube, and 2 cm cube. Okay, so that's 1 volume, 2 volume. So let me just put that here. 1 volume, 2 volume, 1 volume, 2 volume. Okay, so please take note. Whenever you write your equation, always remember to balance. If you don't balance it, you cannot get this right. So when you write your equation, balance it. So now that we have written our 1 volume, 2 volume, 1 volume, 2 volume, we can now go back to the question. So the question told us that methane is what? 0.25 dm cube. It said complete combustion of 0.25 dm cube of what? Methane. So methane is, which is CH4, is 0.25. Okay? They were asked to calculate the volume of what? Oxygen. Now, and pay attention, if methane is 1 cm cube, because we have 1 here, and the question told us that it has a volume of 0.25, and you are asked to calculate the volume of oxygen required for the complete combustion of this 0.25. What you simply need to know is this: if 1 volume is 0.25, what will 2 volume be? Very simple. So if 1 volume is 0.25, what will 2 volume be? Is, for example, if they tell you a crate of egg is 30, how many is in 2 crates? So you simply need to say 2 times 30 to know the total number of eggs in 2 crates. That's what we are doing here. So if 1 cm cube is 0.25, 2 cm cube will simply be 0.25 times 2, which will give us 0.50 cm cube, and that is your answer. So it's very straightforward. If 1 cm cube is 0.25, 2 cm cube is 0.50 cm cube. That is to say that we require 0.50 cm cube to completely combust 0.25 dm cube of methane at STP. So that is simply the answer. So moving on to number 2. 15 dm cube of nitrogen is made to react with 30 dm cube of hydrogen to prepare what? Ammonia. Calculate the composition of the resulting mixture and residual gas. So you are given 2 questions here. You are asked to calculate the resulting mixture, and you are also asked to calculate the residual gas. So let us solve. So like I said, the first thing is to write out your equation. So let's look at the question. We're told that nitrogen is made to react with what? Hydrogen. So nitrogen is N2. Nitrogen is a gas. So because it's a gas, it's written as a molecule, plus oxygen O2, sorry, hydrogen. Also hydrogen is a gas, so H2, and they told us that it was used to prepare ammonia. So we haven't given the product. And what is the formula for ammonia? NH3. So that is the formula for ammonia. So you see that we're actually given the equation, the correct equation, just for us to write the symbolic representation. So now that we're written our equation, it is to what? Balance. So that we don't waste time, you quickly put 3 here and 2 here. So if you are good at balancing, you'll be able to determine that nitrogen on both sides is balanced, hydrogen on both sides is balanced, and also yes, nitrogen and hydrogen on both sides are what? Equally balanced. So now that we've balanced our equation, we can now go back to the question. The first step is to write your volumes as we did here. So 1 volume, 3 volume, 2 volume. You can also say 1 cm cube, 3 cm cube, 2 cm cube. Okay, you can put that there, or you can totally omit it. No difference whatsoever. So now that we've done this, we can now go back to the question. We were told that 15 dm cube of nitrogen, so meaning that nitrogen is 15 dm cube. So we place our 15 here. And then we were told that with what? Hydrogen of 30. So we're going to place our 30 here. Now, was there any mention of ammonia in the question? No, we're not given. So we're going to put a dash here. Simple. Okay, so now that you have placed that dash here, now how do we solve this question? So now let's use the logic we used in solving the first question to solve the second question. Remember, we have to calculate the composition of the residual, composition of the resulting mixture and the residual gas. So if 1 centimeter cube is 15, if 1 centimeter cube is 15, and they told us that 3 centimeter cube is 30. So how do we, or better yet, if 3 centimeters, because now we want to find out what 1 centimeter is. In the previous question, one volume was 0.25, and so we multiplied by 2 to get what 2 volume is. But in this case, we're told that 1 volume is 15 and 3 volume is 30. Now, 15 plus 15 plus 15 will not give you 30. I hope you are aware. So that cannot be our what 1 volume. So we're going to use 3. If 3 volume is 30, what would 1 volume be? So that is 30 divided by what? 3. And that will give us 10. So that is to say that 1 volume is 10. I don't know if you are following. 1 volume becomes 10. And then 3 volume is still 30. Because we're looking for what 1 volume is. And then ammonia is 2 volume. What is 2 volume? If 1 volume is 10, 2 volume was 20. So this becomes 20. So let's use our CMQ. I hope we are following. So if this is 20, the question now says calculate the composition of the resulting mixture. Resulting means what was formed. What was the result of your reaction? And our resulting mixture is what? Ammonia. That is our product. So what is the composition of ammonia? Is 20. So to answer number 1A, which is composition of the resulting mixture, our answer is what? 20 centimeter cube, which is what? Ammonia. Then for our second question, which is what? The residual gas. Residual is what was left behind. That's the meaning of residual, what was left behind. So we're going to be doing subtraction. I totally forgot that. So 15 minus 10 is 5 centimeter cube. Okay, 30 minus 30 is 0 centimeter cube. And then of course this remains 20. So it's minus, not division, minus. So you minus 10 from 15. The 15 we were given in the question minus 10. Then your 30 minus 30 will give us 0, and then your 20. So to get your result, residual gas, residual means what was left behind after the reaction. So 5 plus 0 plus 20 is your residual gas. So 5, 0 plus 20, which will give us 25 centimeter cube. So meaning that the volume of our residual gas is 25 centimeter cube. I hope you understand. So I would love us to attempt this question on our own. So pause the video, attempt it, then play it to see if you are correct. Then let me know in the comment section whether you are correct or not, so that I know whether you are following. So, but that said, let's take the last question. Last question says the following reaction occurred when 100 centimeter cube of carbon 2 oxide was burnt in 70 centimeter cube of oxygen. Then they will give us the equation, which is very unlike the previous questions, and the equation was already given. They now said calculate the total volume of gas mixture in brackets residual gas, assuming constant temperature and pressure. So this is a WAEC question. So let's see. So we're already given the equation, so we don't need to rewrite another equation. You simply copy the equation as it was given, which is just 2CO plus O2 to give us 2CO2. It's already balanced, but you can also check it's already balanced. So now, as usual, 2 volume, 1 volume, 2 volume. So you can also write your 2 cm cube, 1 cm cube, 2 cm cube. Okay, so now that you have done that, you go back to the question. They told us that carbon 2 oxide, which is CO. So please take note, carbon 2 oxide is CO, carbon 4 oxide is CO2. Sometimes you are not given the equation, so don't mistake the two. Carbon 2 oxide is CO. Another name for CO is carbon monoxide. Then carbon 4 oxide is CO2. Okay, and another name is carbon dioxide. So that said, they told us that CO2 has 100 centimeter cube, so we'll put our 100 centimeter cube. And then they told us that was burnt. They said the following reaction occurred when 100 centimeter cube of carbon 2 oxide was burnt in 70 centimeter cube of oxygen. So oxygen is 70 centimeter cube. We were not given carbon 4 oxide. CO2 is what? Carbon 4 oxide. So this will be dash. So now we can now use the logic. We want to now know what 1 cm cube is. So they told us that 2 cm cube is 100, and then we know that 1 cm cube here is 70. But 70 plus 70 will not give us 100, so we cannot use this as our 1 cm cube. So we're going to be using 100 because it is 2. So if 2 is 100, 1 will be what? Half of 100, which is what? 50. So this becomes 50 centimeter cube, and this remains 100 centimeter cube. I hope we are following. Then our 2 volume is also 100 because it's 2. So this becomes 100 centimeter cube. So we can now subtract. 100 minus 100 is 0. 70 minus 50 is 20. And then we have 100. So the question says what? Calculate the total volume of the what? Residual gas. So just one question. So residual is what is left behind. So our answer is 0 plus 20 plus 100, which is equal to 120 centimeter cube. So that is our final answer. So you can see that the Gay-Lussac law questions are not difficult. You just need continuous practice, and this applies to all your gas laws, whether it's Bohr's law, Charles' law, general gas law. You just need to keep practicing. The more you practice, the more familiar you will be with other types of questions, other problem questions under gas laws. So please, if you have any problems, any questions, let me know in the comment section below. Also, if you have specific questions you would like me to solve, also let me know in the comment section below. Till next lesson, I remain your tutor, Ogenetejiri Mamogo. Have a wonderful day.